Hello Math 3A, welcome to examples from problem set number 4. Example 1 is describing a right triangle. So there's a house. Okay, this is my house. I mean, not literally my house, but I'm drawing this house. And then this is going to be the ground. And hopefully your house or my house is standing upright, so that's a 90-degree angle. And then a ladder, and by ladder I mean an extension ladder, or you could just think of it as a board, is laying across like this. So it's creating a right triangle. And then this is going to be moving because the base is moving, so somebody's dragging the ladder out like this, and this side's going down. So you could call this side X and this side Y, and then you could do a Pythagorean theorem. So slightly different, but same principle is this. So there's the ground right here, and then a person is standing 200 feet away. So the person is 200 feet away, and the balloon starts going up at 20 feet per second. For anything that's not going to change, you can actually use the number. If it's going to change, you do have to use a variable. So the balloon is going up, so this needs to be a variable. I'll call that Y. This is not changing because it doesn't say that the person is running away because they're afraid of the balloon or something like that. So this is going to be 200 feet. And then how fast is the distance between the person and the balloon changing after 1 minute? So this is the person here, and then they're looking up at the balloon like this. So the distance between them is this, and I'll just call it B for balloon, the distance between the person and the balloon. And this is a right triangle, and then we could do the Pythagorean theorem. So that's the good old B squared equals Y squared plus 200 squared. And now we're going to need to use this equation in two different ways. One way is this information is telling us that we can find out what B and what Y equal at that moment. So that's basically algebra. And I'm going to do that over here. So the algebra part is, well, for one thing, 1 minute is 60 seconds. And I do need to use 60 seconds because this part over here is in seconds. So 60 seconds, if it's going 20 feet every second, and then you do that for 60 seconds, then seconds and seconds will cancel, and we get that it's going to be that Y is going to be 20 times 60, so that would be 2 times 6 is 12 with 2 zeros, and then that is going to be the height of the balloon after 1 minute. Then we can take this and substitute it in here to find out what the B equals. So this is still under the algebra part. So then B squared equals the Y squared plus the 200 squared. So just plugging in a 1200 right here, and then take the square root of both sides, which is a great time to use my red pen to find out what the B equals. So it's then going to be the square root of 1200 squared plus 200 squared. So at that moment, the B is equal to 1216.553. Okay, now we take a break from the algebra part and we do the calculus part over here. So I need to take the derivative. So doing the power rule, the derivative of B squared is going to be 2 times B. And then the chain rule says, now you need to take the derivative of B. So then times B prime. So B prime means how fast is this changing. So B prime is actually what we need to solve for. On the other side, it would be very similar. It's going to be 2y times y prime. And y prime means how fast is this changing. and that is the 20 feet per second. Oh, by the way, this is just a constant, so the derivative of that is 0. So now I need to plug in all the information we have. So the given information is that the balloon is going up at 20 feet per second, so y prime equals 20. So I can plug in the y prime, I can plug in the b, and I can plug in the y. Oh, I could also divide both sides by 2 and just have these 2's cancel. That would make it a little bit simpler. And then if I'm solving for b prime, how fast is the distance between them changing? I just need to divide both sides by b. So let me just do that before I plug in the numbers. All right, now plugging in the y is the 1200, the y prime is the 20, and the b down here. So b prime is going to equal, the y is 1200, the y prime is 20, and the b is 1216.553. Now, since the balloon is going up at 20 feet per second, I think this would be something sort of close to 20. Like if I get 800, I'm going to check my work. But if I get something close to 20, I'm going to believe it. So let's see. 1200 times 20 divided by the 1216.553. Yep, that's something pretty close to 20. So 19.728. So b prime equals 728, and that would be in feet per second. And then if you look at the second page, it says to use the PERT formula, or exponential growth formula. So I made up a wonderful little example. It's not the lottery, it's about this town that's been growing. So in 2020, they had 1,000 people. 5 years later, 2025, it's grown to be 4,500 people. Maybe they opened a casino near there or something, but anyway, this town is growing fast. So use the PERT formula. And in the PERT formula, this needs to be the beginning amount. So the beginning amount was 1,000 people. So the formula is going to be A equals, the beginning amount is 1,000. And then the R would be the rate of growth, which is not given. It doesn't say it's growing by 10% or something like that. So I'm going to have to find the R myself. So I'll just put the letter R. And then T means the time. So of course, this is a gap of 5 years. And then after 5 years, the amount of people is going to be 4,500. So I need to put 4,500 in place of A. All right, now to solve for R, one thing to do is divide both sides by 1,000, which is where the red pen comes in handy. And then I could have these zeros cross off, and that is actually going to be 4.5. And then the next thing to do to eliminate E is take the natural log of both sides, because natural log and E cancel each other out. And then divide both sides by 5. So the natural log of 4.5 divided by 5, that's what R equals. And then since I can't do that in my head, I'm going to go natural log of 4.5 divided by 5. So that town is growing at about 30% per year, or in decimal form, 0.301. Okay, so for one thing, find the function. So I'm ready for that. So A of t, the function, equals the beginning amount, 1,000 people, e to the rt, and r is the 0.301 times t. All right, so this part, find the function, is done. Then plug in a 10 and explain what that means. So when you plug in a 10, it's going to be 1,000 e to the 0.301 times 10. So 1,000 e to the 0.301 times 10. Oh my goodness. So that means the town is going to have 20,287.4 people. So this is people. And let's see, this means 10 years later. The story started at 2020, so 10 years later would be 2030. So in 2030, that's how many people this town is going to have. They're going to need to build some new houses, I think. All right, the next thing is find the derivative and then plug in the 10. So first of all, the function is right here. And the good news is the derivative of the e function is the e function. So finding the derivative is not going to be too difficult. It's going to be the same function. And then there's one extra thing. The chain rule says you also need to take the derivative of this. So the derivative of t will be a 1, so it's just going to give us the number multiplied by 0.301. Okay, so that's find the derivative. And then the next thing is plug in a 10 to this one. So the derivative, when you plug in a 10, will be the 1,000, the e to the 0.301 times 10. And then because of the chain rule, it's times an extra 0.301. So this was actually the last answer that we got. So what I could do is just screen grab that and say then multiply by a 0.301. And then that gives us the number 6,106.507. And because this is the derivative, that means how fast the town is changing. So the town is changing. Again, this is 10 years later, so in 2030, the town is growing by 6,106.507, and this would be people per year. Because the t right here is in years, so that means this is also per year.